Today we will be going over question 1 of the limiting reagent and percent yield practice worksheet. To begin, the first part, A, asks us to balance and predict the product of copper 2 chloride and sodium nitrate. The products are determined through a double replacement reaction, and the subsequent balancing is done so that there's an equal amount of elements on both sides. Moving on to part B, which asks for the amount of sodium chloride formed, it is necessary to convert both of the given reagents into sodium chloride, the lower of the two being the amount able to be formed. Given 15 grams of copper 2 chloride, it must be divided by its molar mass of 134.45 grams in order to be converted into moles. After converting to moles, the mole-to-mole ratio of copper 2 chloride and sodium chloride is applied, that being 2/1. Afterwards, the now moles of sodium chloride is multiplied by its molar mass of 58.44 grams to convert it into 13.0 grams of sodium chloride. Another calculation must be made to verify that this is indeed the amount of sodium chloride capable of being formed. The other given value, 20 grams of sodium nitrate, must be converted into sodium chloride. Like the first part of B, the 20 grams of sodium nitrate is divided by its molar mass, multiplied by its mole-to-mole ratio, and finally, sodium chloride's molar mass. This results in 13.8 grams of sodium chloride. Because this value is greater than the 13.0 grams derived from the copper 2 chloride, the amount of sodium chloride that can be formed is 13.0 grams. Part C is rather simple. It's only asking for the calculation of the limiting reagent, which is basically the reactant limiting the number of products capable of being produced. Because the answer for part B in 13.0 grams stems from copper 2 chloride, the limiting reagent is copper 2 chloride. Part D is very similar to part B, the only difference being that instead of calculating for sodium chloride, we are calculating for copper 2 nitrate. We can skip a step here because we already have a knowledge of the lesser reagent. Because the grams of sodium chloride for copper 2 chloride was smaller than the grams of sodium chloride for sodium nitrate, we only have to calculate copper chloride's conversion to copper nitrate. Setting up the equation, the copper chloride is divided by its molar mass, multiplied by its mole-to-mole ratio in 1/1, and molar mass of copper 2 nitrate, 58.44. The answer, in accordance with sig figs, is 20.9 grams of copper 2 nitrate. Part E utilizes the concept of limiting reagents to calculate excess. In this chemical equation, the excess is sodium nitrate. Like most equations before this, the 15 grams of copper 2 chloride is first converted to moles through division by its molar mass. Now applying the mole-to-mole ratio and finally multiplying by sodium nitrate's molar mass results in 19.0 grams of sodium nitrate, in accordance with sig figs. This value is the amount of sodium nitrate necessary to perfectly react with the given amount of copper 2 chloride. By subtracting the given 20 grams by the newly calculated 19 grams, the amount of excess reagent is 1 gram. The final part, F, requires that we utilize previously calculated values. With a given of 11.3 grams of sodium chloride, we must use our theoretical 13.0 grams as a denominator. By dividing 11.3 grams of sodium chloride by 13.0 grams, we get 0.87. When made into a percent, it equals 87%. That is all. Thank you very much for listening to today's section of Porciento. Hopefully that helped you out.
Thanks, Ackermann.